So it says a 40 kg girl and an 8.4 kg sled are on a frictionless ice of a frozen lake, 15 meter apart but connected by a rope of negligible mass. Frictionless is misspelled here, but please just ignore that. And so the position is, here is the girl, let's say, and here is the sled. They are 15 meter apart, connected by a rope, 15 meter here, and the rope's mass is negligible. The girl exerts a horizontal force of 5.2 Newton on the rope. So what are the acceleration of the sled? So what the girl, and how far from girl's initial position do they meet? So girl's mass is given, let's say mg, 40 kg, and sled's mass is given ms is equal to 8.4 kg. We need to find sled's acceleration, girl's acceleration, and how far from girl's position do they meet. It should be an apostrophe there, girl's position. So there's a misspell there as well, so whatever. So how far from girl's initial position do they meet? These three we need to find. So the girl exerts a force of 5.2 Newton. Both the girl and the sled will have acceleration according to their mass. So sled's acceleration will be F over ms. So that will be 5.2 Newton divided by 8.4. I guess that's the sled's mass. So it will be 0.62 meter per second square. And girl's acceleration will be ag, F over mg. So that would be 5.2 divided by 40, and that gives us 0.13 meter per second square. So these two are the acceleration that we needed to find. Now we need to find how far from the girl's position do they meet. So both the girl and the sled will have an acceleration. So if we recall this formula, s is equal to ut plus half at square. We have the distance traveled by a particle or an object when we know the acceleration, the time, and initial velocity. In this case, the initial velocity of both the girl and the sled will be 0 because they were standstill, so we can ignore that. And let's say they meet x meter away from the girl. So the girl goes x meter, that will be x here, half a g t square. That will be the equation for the girl's displacement. And for the sled's displacement it will be 15 minus x, because that much will the sled will travel. So 15 minus x will be half a s t square. This is, let's say, equation 2. Now in this case, in both cases, t will be same, because when they meet, they will meet after a certain time. So t is same. So we can substitute t and we can equate them. So x over half ag equals to 15 minus x over half as. These two equals to t square. So we can just equate this term and solve for x. These two and solve for x. So half and half getting cancelled. So this is x divided by 15 minus x over ag divided by as, and this is 0.13, this is 0.62 if I am not wrong. Yes, so this is becoming 0.21. So x 15 minus x is equal to 0.21. So x is equal to 3.14 minus 0.21x. It's becoming 1.21x equals to 3.14. So x is 2.6 meter. So 2.6 meter away from the girl they will meet. So the girl will go 2.6 meters and the sled will go 15 minus 2.6 meters, whatever that is. So